Hi guys, so today I'm going to be talking about U substitution, which is the current, or what was discussed last week for the Math 132 students. And it's a very common way to solve integrals. It's kind of a loophole method, I would say. When you get to an integral that you don't know how to solve, I highly recommend, if you can't apply a simple rule to it, to use this method, because most of the time, and especially in this course, it is going to work for you. So here I just have a basic example. Now, some of the problems will have like maybe a squared or a cubed. And to get that answer, you actually would just multiply them out and then just apply the power rule to each term. But for the most part, they'll give you something like to the fifth or something higher, so you know you don't have to do that. I don't know, it should work either way, so I really don't know why it matters, but some problems they want you to do it fully multiplying it out. But they would maybe be squared or cubed, but nothing higher than that. But for this problem, I am going to use U substitution. So we get to a problem here where you can't apply the power rule because you have a function inside of a function. Kind of think of chain rule where you have an inside and outside function. That's a way of figuring out that you need to use U substitution. And then which one you apply the U substitution to, or which one will be your U, it's typically your inside function. So here you'll see that I'm going to make 3x plus 5 my U. And then, since this is a substitution, we are substituting. So you need to find a u and then a du. So we're no longer going to have an integral in terms of x. We're going to have an integral in terms of u. So my only options for u in this one would be the cubed, which you really can't do that, and then the 3x plus 5. So we're going to take 3x plus 5. And then to get du, that's just the derivative of u. So du is the derivative of 3x plus 5, which is just 3. 3, and then dx. So you think of this as the derivative of u with respect to x. Because you took the derivative of u, but then you in turn took the derivative of x. So then to solve, so we need to substitute an expression for dx. So you divide both sides by 3. So then you just get dx is equal to du over 3. And so instead of 3x plus 5, we're going to put a u in its place. And then instead of dx, we're going to put a du over 3 in its place. So that's how the substitution part works. So I'm just going to go down here and write it out, substituted. And make sure when you do substitute these in that you do them all at the same time. It can get confusing if you decide to substitute the u first, but then keep dx here instead. And then what I like to do also, I don't know if they taught you this last week, but if you have a constant that is multiplied into the expression, you can pull it out. And I say only multiplied, not if it's added or subtracted, you can't pull it out. Because if you notice with derivatives, it's very common that when you take derivatives and antiderivatives, if you have a constant being multiplied into the expression, it doesn't get affected. So, and remember, this is over 3, so this is actually a 1/3 I'm pulling out, not a 3. I like to do this for 2 reasons. One, it makes it look a little simpler, and 2, it is very easy to forget about it when you have it over here. So then I'm just going to apply the power rule for integrals. So you'll get u to the 4th over 4. And then I'm going to keep my 1/3 out front here, which is equal to u to the 4th over 12. And then lastly, to complete the problem, you resubstitute your u expression back in. So it's actually 3x plus 5 to the 4th divided by 12. And then last but not least, do not forget to put your plus c on the end. And then this will be your final answer. Whoops. And that's how you do U substitution on a simple problem.